Welcome. Let's try to solve another Leetcode problem, 306 additive number. So we are giving an additive number, so that is a string, so whose digits can form an additive sequence. So the additive sequence is a Fibonacci sequence. So for example, for this one, it is 1, 1, 1 plus 1 equal to 2, 1 plus 2 equal to 3, and 2 plus 3 equal to 5, and 3 plus 5 equal to 8. So this we're gonna get a Fibonacci sequence. If we can get it, we're gonna return true. Otherwise, we're gonna return a false. But we need to take care of the leading zeros. So for example, we cannot have a sequence like 1, 2, and 0, 3, because for this 0, 3 has a leading 0. Yeah, so for like 1, 0, 2 is invalid because 0, 2 has a leading 0. But if we have a numbers just like 0, it should be okay. So for example, if we have 0, 1, and 1, so this is okay because it only has one number. Yeah, but if it has more than one number, it has two numbers with a leading 0, definitely this is invalid. So we need to check this kind of a testing case. So yeah, we're gonna return true if the additive number, if it is an additive number. Otherwise, we're gonna return a false. And we also need to consider that the additive sequence should contain at least 3 numbers. So it means like this: it should at least have 3 numbers, except for the first 2 numbers. So it's subsequent. It means this number subsequent. Yeah, must be the sum of the preceding 2. The preceding 2 is 0 and 1. Yeah. So normally, how can we solve such problem? Definitely, this is gonna be, a backtracking problem. So for example, we have some numbers like 1, 1, 2, 3, 5, 8, and normally we need to find a sequence. So for example, we find a sequence like this 1, 1, 2, 3, 5, and 8. It's gonna meet the condition. We're gonna return true. Yeah, so this means for the backtracking, we're gonna need a sequence, and we're gonna use the array to represent the sequence. And normally we need to put all the numbers inside of the sequence, and this sequence should be more than and equal to 3 or more than 2. Yeah, because this is according to the question. It must be more than and equal to 3. Yeah, and also it needs to meet the conditions. The first 2 numbers. So for example, if it is 1 and 1, it must be 1 plus 1 equal to 2. It must meet this kind of conditions, or 1 plus 2 equal to 3, or 2 plus 3 equal to 5. Yeah, and 3 plus 5 equal to 8. And we also need to check the condition. It means inside the final array. So for example, this is the result array. If we have a number 1 and 1, so for the next number, it must be a 2. If we find a 2, we're gonna put a 2 inside. Yeah. Otherwise, we're gonna check the next. If there's no 2, so definitely we're gonna break it. Yeah. This is another situation we need to check. So this is a 1, we can put the numbers inside our final array, inside the result array. Yeah, so if everything's okay, we get a final array, and this index from 0, and we also need to prepare an index, goes out of the range. Maybe this I index equal to n is the length of the string. So if it goes out of the range, and still we get a final result, and this result, the length of the result is more than and equal to 3, so it means this is true. If we cannot get this kind of condition until I to the end, so we're gonna return a false. Yeah. So this is basically the backtracking part. Now let's start coding. So we're gonna prepare a variable n. It should be length of the string num. And now we're gonna define the backtracking function. It's gonna be start from the index 0, and I will prepare a result array. So this result array would be empty. So finally, I just needed to call the backtracking function. So inside it's going to be 0 and empty array. Yeah. Now I need to design this backtracking function. So I need to check the conditions of the index. So if the index, let's say if the index equal to n, so it means it goes out of the range, so we need to return the length of the result. It must be more than or equal to 3. So this is according to the description. It must be more than or equal to 3. And then we're going to use a for loop to split the string. So for j in range I to n is the length of the nums. Now we need to first check if there is leading zeros or not. So how to check that? So we can check like this: if j minus I, it means the length of the string is at least 2. Yeah. So if it is at least 2 and num I equal to 0, it means it has a leading 0. So we're gonna break the for loop immediately. Yeah. So this is what we must check. So we must avoid 0, 3 or 0, 2, this kind of invalid cases. Yeah. So if there's no leading zeros, so we're gonna start the backtracking. Yeah. But for the backtracking, I think we can calculate. We can use a current variable as the number, because basically we're gonna accumulate all those numbers. So we can put the current number outside the for loop, and we're gonna accumulate all the numbers to check what is my current number. So the current number should equal to current number times 10 plus with the odd nums j minus odd 0. So this is a for example, if we only have a number 1, so what are we gonna do? So current is 0, 0 times 10, it is 0, so the odd. So odd this number 1 minus 0, odd 0, so it's gonna be 1. So if we have a number 11, for example, so the current would be 11. So this means 1 times 10, it is 10, plus as the next number it is 1. So we get a current number. Yeah. Now we have our current number, and we can start to check the backtracking. Yeah. So if the length of the result array is less than 2, yeah, because we need to check that, so the result array should at least have 2, and then we can check the current equal to result minus 2 plus result minus 1, because we need to build a Fibonacci sequence, so we need to check it like that. First of all, we need to check the length. If it is less than 2, definitely we're gonna put it inside of the result array. So if it is more than or equal to 2, we're gonna check the current. So if the current equal, definitely we're gonna put the current inside of the result array. So result array should append this current number. So it means this can build a Fibonacci sequence. Now we need to check the backtracking function. So if this backtracking function is true, so from the currently it's gonna form j, because this is a for loop to check if it meets the conditions from the j index, so it will go to the next. So it's gonna be j plus 1. So it's gonna be j plus 1 to the result. So if this backtracking is true, definitely we're gonna return a true. Yeah. Otherwise, because it is a backtracking, we need to check the next backtracking, next recursive function. Maybe we backtrack, pop it out, and we check the next. So the result should still need to pop the current value. So we can use the result.pop. We're gonna pop this number and check. Yeah. I think this is gonna be the entire function. Yeah. Let me just have a check if anything is okay. If everything is okay, so this should be okay, and I put it inside and I check it. Yeah. So if there's no true, I'm gonna return a false. I mean, for the backtracking function, if I checked all of them, I cannot get a true. So it means I cannot find an array whose length is more than or equal to 3. Definitely, I'm gonna return false. Yeah. Now let me run it to check. Nums is not defined. Yeah, it is num, not nums. Out of the range. Yeah, because this gonna be if it is a yeah, it must be more than and equal to 2. If the length is less than 2, Yeah, if it is less than 2, it is okay, and yeah, we need to use or, because if it is less than 2, it is okay, and the length of the so if it is less than 2, it is okay. But what if it is more than and equal to 2? So we're gonna have to check this current and equal to the previous two, the sum of the previous two numbers. Yeah. So this is less than 2. Otherwise, it's gonna be more than or equal to 2. So we're gonna use this kind of a formula, the Fibonacci formula, to check the result. Now, as you can see, it should be okay. Yeah, as you can see, it works. But if we were to do some training of the backtracking function, we can have we can check it like this. So if a length of the result is more than and equal to 2, and the current is more than the result minus 1, the previous two values, result minus 2, minus 1, so we can break it immediately. Yeah, because if the length is more than and equal to 2, and our current number is more than, it means the next current number must be more than the sum of the preceding two numbers. Yeah, so this is just trimming from this bronze. Yeah, as you can see, it works. Yeah. Now, let's try to check. So the follow-up is how would you handle the overflow for very long input integers? Yeah, so this means if we want to avoid overflow, for Python it is okay because the length of the string is only 35. Yeah, but for other languages we need to avoid the overflow. So for example, if we cannot, if we cannot produce a big integer directly, we're gonna avoid the overflow. So we can use the string plus to get the final result. So this means we don't need to use this current. Yeah. So let's try to solve it like this. Yeah. So we can delete the current because we will not use it. And for here, we will not use this kind of a formula because definitely we cannot use the plus for big integers. So the current would be equal to a string. So we're gonna get a string. So it's gonna be num from I to j plus 1. So this is my string. And for here, I would to check if my current string equal to a check function. So I'm gonna define a check function. It's gonna be result2 plus result 1, and this check function gonna return a string. I'm gonna check if this string equal to my final string. Yeah, I mean the previous two strings. Yeah, so I'm gonna first check the string if it is okay. So if this current is more than, I'm gonna change it, yeah, still to the check with two strings. Yeah, if it is more than, I'm gonna break. So the next is we just need to define a check function. So we're gonna define a check function. It's gonna be two strings, and currently we just need to, we just need to plus the two strings. So for example, the two strings can become so for example, S1 is 1, 2, 3. Maybe S2 is 2, 3, 5. Basically, we're gonna plus two strings together to get a final string. So the final string would be 3, 5, and 7. Yeah, it's gonna be like that. Now we need to, I think we can use two pointers to point to the end of the string, and then we're gonna plus them together. It's like add two numbers in a linked list. We have the same Leetcode problem like this. So we're gonna prepare I and j. It's gonna be length of the S1 minus 1 and the length of S2 minus 1, because we're gonna plus them from the end to the first position. So first of all, we're gonna plus 3 and 4, and then 3 and 2, and 1 and 2. Yeah, because they're gonna be carries, so we're gonna prepare a carry to be 0 from the beginning, and then we're gonna start the while loop. So while I more than equal to 0 and z more than and equal to 0, so we're gonna prepare a value. So the value, we're gonna turn the s1 I to an integer. So if I more than and equal to 0, else it's gonna be 0. And similarly for the s2. Yeah, so I'm gonna use a parenthesis, and similarly for the s2, it's gonna be s2 z. If z more than equal to 0, else it's gonna be 0. Yeah. Now I still need to check the carry, and I'm gonna plus a carry. Yeah. So this is just to check if it is inside the boundary. Yeah. So here I need to use the all because I'm not sure which one is longer, which string is longer. So I need to use all. Yeah. And I'm gonna prepare the carry. So the carry would be val divided by 10, and I'm gonna prepare the result. Result would be equal to, yeah, result would be a string. So yeah, so the result would be equal to string of val modular 10 plus the final result, and I would be -1 and z would be -1, and finally I need to return the result. Yeah. So basically I need to check if the two strings equal to another number. So for example, it is 1. Maybe this is 8. So it's gonna be 1057. I want to get this kind of a result. Yeah, basically. Now before the backtracking, I'm gonna check if it works. So I would to print out the check function. So I would to check this, testing case this two. Yeah, I would to check if it equal to the result. Yeah, and then I'm gonna just put it inside the backtracking. It should be okay. So let me print it out. It is 057. It means I didn't plus the carry. It should be 1057. So I need to check the carry. So if there is a carry, my result would equal to 1 plus the result. Now let me run it again to check if I get the final result. It is 1057. So this is 1057. It should be okay. Yeah. Now I need to return the backtracking function to check if it is okay. Yeah. There's a lot of coding, but the difficult part is about the backtracking. Yeah. If the backtracking okay, normally this should be easier to write. Yeah. As you can see, it works and it's pretty fast. Yeah. So thank you for watching. See you next time.